A year ago, I came to the conference, and we were all looking at a retrospective over 20 years in the industry. And what I pointed out then was the rise and fall of the fabless semiconductor business model. Didn't talk so much about technology as business model. And if we look at that, the number of fabless semiconductor startups per year peaked at 200 in the year 2000. Then it started to fall. It wasn't so surprising. We had the tech boom bust at that time. What was surprising was it kept falling down to a low of less than 10 last year. It's also less than 10. That was 2010, 2011, and now 2012, running at that very low number. Of course, it's running that low number for the reasons that were just so eloquently expressed, with how very difficult it is to create a semiconductor startup today. You imagine trying to do that, starting with a small group of people to start that right now at the 20 nanometer node. Now, last year I focused on NVIDIA, and we talked about Jason Wang and the incredible things he did, and how in that time frame he was able to start a company that became a $7 billion company today. I would like to take a different focus today. In following Gabriel's lead, I'd like to look at acquisitions. And I'd like to study this. The reason we're doing this is I want to look at the compound effect of the fall-off in fabless semiconductor startups and the acquisitions that are taking place, and then ask the question, what's going to happen to innovation in the industry? So first, Atheros, purchased for $3.1 billion in 2011 by Qualcomm. Then switching around, let's take a look from a different perspective at Broadcom, as Martin talked about. From Broadcom, I'd like to look at the perspective of the companies they've acquired and looking at some of the constellation of companies we looked at last year and seeing what's happened with the acquisitions by Broadcom there and how that's affecting the industry as we look ahead. In the year 2000, Broadcom was already very strong, of course, in Ethernet. In 2010, Broadcom made a prescient acquisition of Dune Networks. Dune Networks was the best, and it just developed low-latency switching. So low-latency switching is what is needed for the east-to-west switching that takes place in data centers. So now they had the combination of what they needed for traditional enterprise networking and what they needed for the upcoming low-latency switching in data centers as that emerged, the prescient purchase. 2011, purchasing NetLogic for $3.4 billion. NetLogic had earlier purchased RMI. RMI was valuable for multiple reasons, but one was that they had NPU. So now NetLogic had NPU capabilities. Earlier, they bought the two divisions of two other companies, and they became the dominant power in TCAMs. So NetLogic, dominant power in TCAMs, RMI, strong in network processing, purchased by Broadcom. So Broadcom was already this far away the leader in switching, and now they're far away the leader in the line card. So with this strength, Broadcom has dominance really beyond the SI, the silicon industry, all the way around worldwide in terms of the OEM industries. You find this as you talk to OEMs around the world today. Let's take a look at other standards. ITT bought Tundra in the year 2009. So they took over serial rapid I/O switching. You might look at that and say, well, not as big a deal. Serial rapid I/O is more limited in terms of using for DSP interconnect, and then additionally sometimes within the military for their interconnect, but a relatively smaller market. But then this last year, IDT bought PLX, bigger buy. Now with that purchase, they're the dominant supplier in terms of PCI Express. They are PCI Express switching. Again, you talk to the OEMs, the major companies, that's what they're dealing with today. So if you look between these two standards with Ethernet and PCI Express and the change in complexity of the industry over the last few years, what was kind of wide open before with multiple suppliers and perhaps multiple opportunities for companies to start up has transformed until now we have dominance by one company in one place and one in the other. It's a shifted industry for us in semiconductors in terms of what can be started up and also for the worldwide electronic infrastructure. In terms of what we just looked at, you would just look at that and might say, well, if not for the startups, it's an ideal world for the big companies dominated. But I'd argue that, in fact, for the big companies, there's some problems as well. And here's what I mean. We're looking now at the tail end of the number of fabless semiconductor startups and that drop off to the year 2010, 11, 12. What's counterintuitive, at least to me, the number of acquisitions has remained relatively constant through this period. So the result of that is that there's actually a target scarcity. So if you look at the major companies, as they're making these acquisitions and growing themselves, they're going to be a target scarcity. So in fact, There's a lack of startups that become a problem, not just for those who want to innovate themselves with a small group of people, but also for major companies as well. In terms of dealing with that, then I'd like to look at the model of business models at the system level, not just at the silicon level, for perhaps inspiration about how we can open up things in our own industry today. If we take a look at cell phones, looking backward, of course, Nokia dominated the industry and had the vast number in terms of sales. The one model alone sold 200 million units, and most of the revenue accrued to Nokia at that time in terms of profit. Looking forward, we have Apple right now dominating the industry in terms of the cell phone industry. Looking across, Nokia had a closed system. So in terms of a business model, it was a simple phone. It was a closed system, right? I like to look at BlackBerry as a bridging function where BlackBerry created the smartphone. From an application viewpoint, it was relatively closed. You had security for your email. You had a few other apps, but it wasn't an open application system. And bridging over to Apple, of course, as a very open system. Let's look a little bit more at the Apple open system model. On the left-hand side of your screen, if you're looking at Steve Jobs over here, this is when he announced the iPhone App Store. Of course, the iPhone was excellent technology, and that already had come out and was doing well. But when Steve Jobs came out and announced the iPhone App Store, this is a picture during that video. When he announced that, he talked to the apps developers like I'd like to talk to IP subsystem developers. He said to the app developers, you're limited in your channels. You don't have very many channels available to you. You're not a very big industry right now. I'd like to change the industry, and here's what I'm going to do for you. So in terms of changing the industry, so starting off, I'm going to open a store. You can set your price. You can share. I'm going to share revenue with you. I'm going to take Apple. I'm going to share my revenue with you. And beyond that, in terms of credit card fees, the underlying fees, Apple will absorb them. So that was his triple model that he used. And with that model, when he announced the store, the number of sales in the next quarter equaled the previous year's sales of the iPhone. So, of course, it was a great technology platform, but it really took off at the opening of the iPhone App Store. And we're showing in the middle here, that was the figure in March when there were 25 billion downloads. There isn't as pretty a picture to show the number of downloads in October, but it was 35 billion. So we all know the iPhone apps have been extremely successful. Looking at the numbers, it's even more remarkable. And in terms of the revenue, then, there's been over $7 billion of revenue. And with the revenue share back to the developers, that's more than $5 billion has gone back to the iPhone app developers. I'd like to look at one more viewpoint in terms of changes in business models. So going with the idea of what's changed in business model can reinvigorate the semiconductor industry. Here we're looking at the business model on data centers. So if you look at data centers, again, if we look backwards, if you were building a data center 5 years ago, you were pretty much faced with buying things off the shelf. And when you went to buy your server rack that you bought for your data center was virtually the same as someone bought when they had a small business and they put it in the closet. The racks were just about the same. So there's no optimization. There was sort of a general purpose approach to it. And from the router viewpoint, if you're building your data center, your top-of-rack routers, all the routers that you had, they were essentially the same routers that were used and were driven in definition by wide area networks, by the general internet, but there was no optimization for what was done there. So it was strictly going and buying from vendors as an individual might do or as a company might do. A major shift has happened there in terms of the business models. Google and Facebook are driving both servers and networking right now. So there's been a dramatic change there, and right now with Google and Facebook, they're writing the specs. So if you look at the specs for the servers right now, they're coming from Google and Facebook. If you walk into the Google, one of their hardware offices, you see their own racks there. They don't necessarily proliferate all their own, but they're perfectly capable of building them and deploying them when they want. They don't put skins on the racks. They have a lot of different things they're doing, different ways they're going to employ flash, different ways the backplanes are going to work, PCI Express starting to take in some of the Ethernet territory. Same token for Facebook. So the combination of two, they're creating the innovation in that industry, and it drives outward from the data center, not into it. So what's the resultant effect of that in terms of the vendors? We take a look at the vendors looking backwards. Of course, Intel dominated with a few forays from AMD in terms of the servers and the server architecture. But the change in that is right now, if you look at it, we're starting to see the first steps of ARM getting in the data center, and there's a number of companies entering that. And there's no question that they're going to make some encroachments, and we'll see how that goes. Another thing I would say there is it's an IP subsystem model, and with that IC subsystem model, there can be a flourish. We can really fulfill a lot of creativity there, And I know some of the people here in the room have their own CPU IP subsystems, and who knows? It isn't a given fact that just ARM's going to dominate. Others may come. Again, as you drill in and see the specific needs of the data center, we're going to see a proliferation. So we're seeing a move from the IDM model over to the IB subsystem model. At this point, I'd like to switch gears a little bit and come out of the cloud and kind of return gradually back to the silicon level, because the underlying question is what business model can be used to revive innovation in the semiconductor industry. So I really asked the question, given that we have some inspiration, hopefully, from looking at these models, what could be done for companies that want to proliferate new standards like software-defined networks? We mentioned the change in data centers in terms of the servers. There's an equally bigger change happening in software-defined networks, and it's a change, again, where they're driving out of the data centers complete new standards. So you might say, what are we going to do with semiconductors such that we can support this? And what can we do to proliferate the standard? What could companies that have visions for new ecosystem standards do to proliferate their visions? At the existing fabless semiconductor model, looking at those companies, what can they do when they want to create a new division, a new product line? They face the same problems as other startups do. To spend $100 million in a new product line is pretty difficult. If you're the general manager of that division, you might choose to forego innovation in a lot of cases. And then finally, we emphasized more last year, is at the IP subsystem level. If you have a small group of IP innovators, you have your subsystem, and you dream of being a superpower, how do you become a superpower in SSPs? How could that be done? So here's what we think are the basics of that. We think you need flexible, powerful silicon. You'd want to have it with ZERO NRE. You need a partnership. If you're going to partner as, let's say, a group that has soft IP and wants to become an ASSP company, you'd like to have a partnership that spans marketing, sales, manufacturing, distribution, logistics, the works. You have to have aggressive pricing. If you're going to have a partner and you're going to create an ASSP company, you're going to have aggressive pricing, whether it's for one unit or multiple units, whatever that you have to approach like that. And then you need to have the capability of developing not just one chip, but a family of chips. After all, we're talking about a major existing company starting a whole new product family, or a new IP company being formed that then creates ASSPs, but not one, but an ASSP family. So it raises the question, what's the business model that's going to allow this bridging to occur, to allow a major change in the industry? We're proposing a business model we call ASAP. From our viewpoint, it stands for Application-Specific ABAX product. Our underlying chips are called ABAXs. When we partner, we call it an Application-Specific ABAX product. So going back to the fundamentals then, going back to the iPhone, if you will, the iPhone was a very good instrument in its own before the App Store opened, so you have to have good underlying hardware. And in terms of underlying hardware, our engineers are hard at work right now, nearing tape out of our first 22-nanometer chip. So for ourselves, our underlying partner is Intel. We're using the Intel FinFET technology. The Intel FinFET technology at 22, those are the fastest CMOS transistors in the world. And believe me, we're using them. We're getting every bit of speed out of that. They have the world's best manufacturing process. It's kind of amazing, but Intel's ramping to the point that 25% of their revenue is going to be in 22 nanometer at the end of this year. So they have great transistors, great manufacturing, and they have about at least a one-generation lead on the rest of the industry in terms of the rollout of their products. The process is good. You have to have an architecture that goes with it. We have something we call our space-time architecture. So our space-time architecture is also very high-performance oriented. So we have high-performance logic, memory, multiplier accumulators, the works for signal processing or network processing. So it's a good marriage, if you will, in our case, between a high-performance process and a high-performance architecture. In terms of we are programmable logic devices that we're providing for this partnership, and the synthesis flow is one that you'd be used to with Verilog or VHDL going through a compiler, creating a configuration stream. Should all look familiar to the design teams. So what does it take then? Take it bottoms up in terms of what we hope to provide and do what we can to bridge the gap. Flexible, powerful silicon. So we have 22 nanometers we've shown you, programmable. We call it our 3PLD or space-time architecture. The devices that we're about to sign off and will be available early next year, rich in logic, rich in memory, rich in I/O. Clearly, you have to have a lot of SerDes and DDR interfaces to support the high performance that we're talking about.
2 gigahertz operation. So I've talked sort of in general about high performance for the products. It is a distinctly different architecture. The result of the distinctly different architecture is the internal core, not the I/O. Internal core can run at 2 gigahertz. So you do have to work with us. You have to optimize some of your RTL. It doesn't happen in every case. But the goal of this is having a 2 gigahertz architecture. It's logic, interconnect, memories, multiplier accumulators. And just as an order of magnitude comparison, typical for the programmable logic industry today is about 300 megahertz, 350 at best. So it's distinctly different, and with optimized implementations can do things that can't be done previously in programmable logic. So really the message today is that we're proposing a new business model, but we're combining that. A new business model without a strong underlying silicon platform wouldn't be worth much. So what we're developing as we speak is an underlying silicon platform based on Intel 22 nanometer, our space-time architecture that allows it to run up to 2 gigahertz in service, ultimately in your service. So the idea of this is to take your RTL, to compile it, to create an encrypted file, and that would go into our chip. So the programmable logic device plus your encrypted chip creates the SSP, plus your encrypted configuration file creates the SSP. Of course, if you have it, it's not enough to have an engineering solution, and you also have to have a marketing solution as well. So we co-brand in terms of parts we develop with it shows one of our partners. We share the marketing. In fact, we take the lead in with our partners if they need that for the marketing. We've talked about the chips. We build boards as well with our partners. In terms of we leverage our marketing capabilities, so we make our marketing machine available to everyone. We have a worldwide sales representative around the world we're covering, and we just added Apple Tech in Israel. One other point. We have a worldwide sales rep organization. I'd like to add, again, just kind of pick up from the Apple thing. We said we're trying to take inspiration from the cloud and from Apple. And the sales fees, in terms of, I'm going to show you the revenue sharing in a moment, but the sales fees are absorbed by us. So we're going to have a revenue sharing model, but underneath that, that's pure shared revenue. There's nothing deducted from that. So this is a picture again of one of the ASAP partners with the chip and the board that we did at 40 nanometers. But I didn't come here today to look back at 40 nanometers. I came to look forward to 22 nanometers. So looking forward to 22, everything we do from our company, that we propose a business model, and it can be used at different levels of performance. In terms of where we'd like to come in and fulfill that business model, it's at the very high end of performance. So we're looking at 40 gigabit, 100 gigabit Ethernet, the highest end of networking. In terms of networking, deep packet inspection, level layer 2, layer 3, layer 4, switching, routing, DPI, and we're working with a partner right now on regex. It can span over to the data center, firewalls, load balancing, and then particularly for software-defined networking with all the flux. It requires changing headers, a lot of lookups, things that happen to match with the architecture. Taking the same theme across in the data center, high volume, high velocity data. We think a lot of things that work well within networking in terms of search, lookup, correlation, CRCs will work well here as well. And finally, looking across at signal processing, again, the theme being the very high end of signal processing. So using a sample here, 10 gigasamples per second. In our cases, we're usually going to be looking at direct RF sampling, connecting directly up to analog to digital converters, the very high end of the analog digital converters. And then examples would be synthetic aperture radar, digital radar, LiDAR, and perhaps going over into optical dispersion compensation. Again, we're looking every time we're looking at the very high end of that. So that's a part of the market that we'd like to open up with these products, and we're making them as available as platforms for discussions with potential partners. So we have worldwide opportunities in terms of looking at this. There's no geographic specificity about this. It's not about just having more startups in Silicon Valley or in any other place. It's worldwide. So right now in terms of our partnerships, we're in talks with partners in Asia, in North America, and in Europe. In terms of the partnership, it can be with a small group of people with a great idea, or it can be with the existing companies, and we are talking with the biggest companies as well. So in conclusion, we look backwards at the rise and fall of the fabless semiconductor model. We looked at the acquisitions that are taking place in the semiconductor industry and the compounding effect that's had in reducing the number of opportunities for new companies. We looked for inspiration from Apple and Google, and we proposed the ASAP business model to invigorate the industry. Our hope is that will spur additional industry innovation in the years going ahead.